Classes, it's like agricultural marketing business. Accounting class.
Figuring out how to run it, how to manage it, how to do your taxes correctly. You know, some cases it's easier to have someone do it for you. Sometimes it's easier to do it yourself, but it's always good to know it just to make sure it doesn't come back to you. We're starting off this chapter pretty easy. Complex numbers. Complex numbers are something y'all have done before. We've done them in Algebra 2. And for the most part, a lot of this chapter is going to be a little rehashing. There is a little bit at the end that is new, that we haven't done before. Okay, good. Just making sure. I'll plug. But the first thing we're doing is nothing new. Complex number, the number a plus bi comes in this form. Is a complex number. And it is written in standard form. We always put the real number first, our imaginary part second. A is a real number because it doesn't have I. Bi is the imaginary part because it has I. When b is 0, the a plus bi number. When b is equal to 0, the number a plus bi is a real number. And when b is different from 0, it's an imaginary number. A number of the form bi where b is different from 0 is called a pure imaginary part. So whenever we just have bi, it's just pure imaginary. When we just have a, it's a real number. But really, any number can be rewritten as a imaginary or complex number, because even if we just have the number 4, we can add 0i to it. So it is an imaginary number, which is kind of coming from our fundamental theorem of algebra, which states that every solution of any higher degree or polynomial function will have at least one number in the complex plane. Kind of this. Nothing too new at this point. The set of all real numbers, subset of the real numbers and imaginary numbers is the complex plane. This is true because every real number can be written as a complex number, as we just saw. So, kind of delving into the next part, addition, subtraction with complex numbers. Well, we add the real parts together, combine the real parts, combine the complex, and go from there. Now, I'm going to do this in the pure mathematical way, the way that they would show it. Do not write this because it's more complicated than this absolutely has to be. So I'm going to show it the complex way first, show it the simple way second. Don't write the complex way. I'll tell you when to write. Because if we do this here, the first thing we can do is drop the parentheses. Since it's plus in the middle, the signs don't change. Now, the next step is to gather the real numbers, our 4 and 1, and our imaginary numbers. Now, at this point here, we need to factor out anything that we have. Well, it's just going to be putting parentheses around 4 plus 1. But for the other part, we're going to factor out I, which would give us 7 minus 6 times I. And we would combine our terms. 4 plus 1 is 5, plus 7 minus 6 is 1. I, and we get this here. I consider this the complex way, or the more intricate way that we really don't have to really look at. Because really what we can say is, well, we have 4 plus 7i plus 1 minus 6i. So we have our real parts 4 plus 1, and our 7i minus 6i. 4 plus 1 is 5, 7i minus 6i is I, telling us that it's 5 plus. That's it. Five plus I is the answer. One plus 2i plus 3 minus 2i. The nice thing about the graphing calculator, 1 plus 2 second decimal will give us I, plus 3 minus 2I. I can type it in exactly as it is. That will give us the answer. And it does work out to just be 4, because our 1 and 3 added together, 1 plus 3 is 4. 2I plus negative 2I. 2 minus 2 is 0. So we do it indeed, just get the real number 4. That's it.
Could you type in the calculator, say like the first column?
Yeah. We get the same thing. So 4 plus 7I plus 1 minus 6I. 4 plus 7I plus 1 minus 6I is. I mean, these next two, we could type them in exactly as we see them. Now, I'm going to write the first one out, C, because we would have 3I. Because of this minus in front of the parentheses, we will have to distribute it out if we're doing it by hand. Our negative 2 is going to become positive 2. Our positive 3I is going to become negative 3I. Same thing with our second set of parentheses. Our positive 2 is now negative 2. Our positive 5I is now negative 5I. And now at this point, we can combine like terms. Our positive 2 minus 2 is 0. 3I minus 3I is 0, leaving us with negative 5I. 3I minus, what was the next part? Negative 2 plus 3I minus
2 plus 5I.
That's it. Questions on this here? Distributive property, multiplication. So if we do this here, all we're going to do is multiply through. If we have a number in front. So our properties of multiplication, distributive properties still hold true. 4 times negative 2, negative 8. 4 times positive 3I is plus 12I. Negative 2 plus 3I. Exact same thing. Questions on this here? All right. Now we're going to look at the next one here. So 2 minus I times 4 plus 3I. So again, we can still use our distributive property. 2 times 4 is 8. 2 times 3I would be plus 6I. Negative I times 4 is negative 4I. And negative I times 3I is going to be negative 3I squared. Questions on this so far? Now at this point here, we would combine like terms. So we have our 6I minus 4I, which would be plus 2I minus 3I squared. Now there is more steps to it, and we'll get to that in a second. Now, if we type it in a calculator, 2 minus I, 4 plus 3I. 2 minus I times 4 plus 3I. We don't have to put the multiplication between the two sets of parentheses. The calculator understands when we have two sets of parentheses right next to each other that we are indeed multiplying. Enter, we get 11 plus 2I. That's a little different. Yes? Because it doesn't give us the negative 3I squared. Now we didn't delve too much into it for this here because some of it's we're glossing over because it's kind of understood at this point. But I is understood to be the square root of negative 1. That's all of our base of all complex numbers. I is the square root of negative 1. So here, this part that wasn't included, the negative 3I squared, well, the I squared part's what's coming into play. because if I is the square root of negative 1, when we say I squared, we're saying that we're taking the square root of negative 1 squared. Well, a square root and square would simplify, telling us it's just negative 1. So really what we have here is 8 plus 2i minus 3 times negative 1. Well, negative 3 times negative 1 is just positive 3, yes? And 8 plus 3 is 11. That's it. And out of all the ones to be familiarized with, especially with powers of I, we'll cover those in a minute, probably at the end. I squared being negative 1 is one to be kind of familiar with, because it's one of those that's easy to fix, easy to change. Anytime we get an I squared, change it to negative 1. We'll do another one of these here by hand, and I'll kind of show you how I would do these. When we distribute, 3 times 3 is 9. 3 times negative 2i is negative 6i. 2 times 3i is plus 6i. 2i times negative 2i would be negative 4i squared. Now we just said I squared is negative 1, yes? Which really is just going to take whatever the sign of this and turn it from negative to positive or positive to negative. So if it's already negative, I mark I out and change the sign. If it's positive, I mark out the I squared, I mark out the plus, change it to minus. Now if it's just I squared, that's just negative 1. So I'll mark it out and just put a 1 in its place and then change the sign accordingly. Now 9 plus 4 is negative 6i plus 6i is and yes, we could have gone in the calculator and said 3 plus 2i times 3 minus. And gotten 13 also. Questions on this here? Even 3 plus 2i squared. Really that's saying that we're multiplying 3 plus 2i by itself. And then we can do our distributive property. 3 times 3 is 9. 3 times 2i is plus 6i. 2i times 3 is plus 6i. And 2i times 2i is plus 4i squared. As we said, the I squared is negative 1, which is really just going to take that from positive 4 to negative 4. Then we can combine like terms. 9 minus 4 is 5. 6i plus 6i is plus 5. And that's it. In the calculator, parentheses 3 plus 2i. Now I could retype it back in, parentheses 3 plus 2i, close parentheses, enter. Or I can hit square, get the same thing. Questions on this here? I think we feel pretty comfortable with multiplication, addition, subtraction. Complex conjugates. This occurs when pairs of complex numbers of the form a plus bi and a plus minus bi are called complex conjugates. So whenever we have a complex number, if we change the sign in front of the I, our imaginary term, it is its complex conjugate. And interestingly enough, when we multiply them together, we get a real number every single time because the I terms will cancel out. I squared becomes negative 1, and it simplifies down. Or really, it's the first terms, the number of our real term squared, plus the number in front of our I squared gives us the value also. or we can plug them into the calculator to see what their product is. So 1 plus I, if we're multiplying it with its conjugate would be 1 minus I. And we multiply this together. 1 times 1 is 1. 1 times negative I is negative I. Positive I times 1 is plus I. And I times negative I is negative I squared. And as we've seen already, I squared is negative 1. So it'll make it plus, but because we don't have a number there already, we go on and fill it in as 1. We don't normally have to write that if there's a number in front of our I squared term, because like the ones we've had before, 4 or 3, because 4 times 1 is 4, 3 times 1 is 3. It doesn't change the number, but because we don't have a number there already, we got to fill the 1 in. Our negative I plus I will cancel out, and 1 plus 1 is calculator will do it for us. Graphing calculator more specifically. The 30XS will not calculate these for us. 4 minus 3i's complex conjugate would be 4 plus 3i. And again, we can type this in, do it by hand, or as our sheet a minute ago said, a squared plus b squared. So our a, we'll do these in both ways. Term is 4. Our b term is 3. 4 squared is 16. 3 squared is 9. So I'm saying this should be 25. If we work this out, 4 times 4 is indeed 16. 4 times 3i is plus 12i. Negative 3i times 4 is minus 12i. And negative 3i times 3i is negative 9i squared. Well, our 12i minus 12i is 0. Our I squared turns it from negative 9 to positive 9. And 16 plus 9 is, lo and behold, 25. Calculator will tell us the same thing. Questions on these here? Well, the reason that we have these and the reason these are helpful is with simplifying fractions, because we can't leave I in the bottom of a fraction. Part of the reason is that we're leaving really the square root of negative 1 in the bottom of a fraction. We don't like leaving radicals in the bottom of a fraction. So we do need to simplify this. Now the way that we simplify it is I'm going to multiply this fraction by 1. Well, it is 1. It's just a fancy version of 1. And we're going to use the complex conjugate of the denominator. Our denominator is 4 minus 2i. So its complex conjugate is 4 plus 2i. And we're going to multiply this fraction on top and bottom by 4 plus 2i. And as I said a minute ago, we are multiplying this by 1. Because 4 plus 2i divided by 4 plus 2i is 1. We can multiply anything by 1 because it doesn't change the number. This here will change how it looks, but it won't change its value. Now the denominator, when we multiply through, 4 times 4 is 16. 4 times 2i is plus 8i. Negative 2 times 4i is negative 8i. And negative 2i times 2i is negative 4i squared. And as we've seen already, the I squared is going to turn that from negative 4 to positive 4. Our 8i, negative 8i cancel, and 16 plus 4 is 20. Now we do need to simplify the numerator. 2 times 4 is 8. 2 times 2i is plus 4i. 3i times 4 is plus 12i. And 3i times 2i is plus 6i squared. And as we know, the I squared is negative 1. So it's going to turn it from positive 6 to negative 6. 8 minus 6 is 2. 4i plus 12i is plus 16i. And we get this here. Now, for those of you who've had me for Algebra 2, we've gone over how to actually plug these in, because you can plug these into the calculator. And as we saw, the 84 plus, the TI 84 plus, has issues with these. It doesn't like plugging them in. So we had to do parentheses around the numerator, hit the division key, parentheses around the denominator, and we get our answer. It always gives it to us in the form of a decimal. So we went math, enter, enter to turn it from decimal back into fractional form, and we got our answer. But the TI 84 plus CE does not have this issue. Because for the CE version, we can go alpha, y equals, enter. We can pull the fraction up. And then we can type it in as we see it, 2 plus 3i over 4 minus 2i. Y equals 2 plus 3i over, is it 4 minus 2i? Okay. And we get this here. Now this is the correct answer. 1/10 plus 4/5 I. It's just we have to do one little step. Because here, for the most part, I would take this, but this isn't technically in standard form. Because standard form comes in the form of A plus BI. They're split, they're not one fraction. So here we would split the fraction up. So it tells us that we have 2/20ths plus 16/20ths I. 2/20ths would reduce because they both have a common factor of, which would be 1 over 10. 16 and 20 have a common factor of 4, which would reduce 16 to 4, 20 to 5, I, which is exactly what the calculator told us. Questions on division? So really, even with this one here, we can plug it into the calculator and let it do it for us. Yes? Okay. When a is a positive real number, the principal square root of negative a, defined as the square root of negative a, is equal to the square root of a times I. Personally, especially when we have a radical, I try to put the I in front of the radical so it's easier to see that it's not still inside. To each their own. Now, for the most part, these here, there's some of these we can do in the calculator and there's some that we can't. Because if we look at the first one, the square root of negative 3 times the square root of negative 12, we can type it into the graphing calculator. Between auto and radians, we do need it to read a plus bi. If it reads real, it's not going to work. And to change it, we go into mode, down to where you see real about halfway down the screen. We scroll down to it, cursor over onto a plus bi, hit enter, and we can go stack and quit. So it will let us take the square root of negative 3, second square root, was it negative 12? 12, and hit enter. And it is negative 6. Now the only issue that we have with the graphing calculator, I'm just going to change it to 13, is if the number that we end up with is not a rational number. Then we have to actually do these by hand, or do it a little differently. Because if we did this first one by hand, well, the negative in the square root of negative 3 would come out as I. So we'd have I squared of 3. Square root of negative 12, the negative would come out as I, and we'd have the square root of 12. Now we can multiply these together, and there's different ways we could have done this. I times I gives us I squared. Square root of 3 times square root of 12. Since they're both the same radical, 3 times 12 is 36. What's the square root of 36? 6, because 6 times 6 gives us 36. So the number multiplied by itself that gives us 36 is 6. I squared is, so it makes it negative 6. Questions on this here? So some of these, if we tried the next one, square root of negative 48 minus the square root of negative 27, we can type this into the graphing calculator, and it will indeed give us an answer, but it'll be a decimal answer. Because if we look at the square root of negative 48, well, the negative is going to come out as I, leaving us with the square root of 48. Yes. Minus negative 27. The negative will come out as I, leaving us with the square root of 27. Now the 30xs will not do negative radicals. Negatives inside of a square root and even root, because it's an imaginary term. It does not exist. So we've kind of started working this out, yes? Is the square root of 48 a real number now? Yeah, there's no negative inside of it. So I can grab 30xs, say second square root 48, 4 square root of 3, which tells me that this is now 4I square root of 3 minus, I can do the same thing now with square root of 27. So it'd be 3I square root of 3. Well, 4I square root of 3 minus 3I square root of 3. I have 4 of them. I take 3 away. What I have left is 1I square root of 3, or just I square root of 3. Yes. Questions on this here? But even before doing all those steps, I square root of 48 minus I square root of 27, both of them have I in them, yes? So whatever I get as my answer should have I as well. Square root of 3, add I back to it, I square root of 3 is the answer. Now if it worked out to be 0, well, we would have 0I, which is just 0. Negative 1 plus the square root of negative 3 squared. For one thing, we are going to have this thing twice, yes? But we do need to simplify the square root of negative 3, because that's just saying that it is I square root of 3. Now at this point it'd be very tempting to want to throw this into the graphing calculator, let it do it for us. But the square root of 3 does not simplify, so that does throw a little wrench in there. And the I term does make things a little interesting also. But we can go on and do our distributive property. Negative 1 times negative 1 is 1. Negative 1 times I squared of 3 is negative I squared of 3. I squared of 3 times negative 1 is negative I square root of 3. And I squared of 3 times I squared of 3 is plus I squared times, well, square root of 3 times square root of 3. There's 2 ways at least 3 ways we could say this. Is the square root of 3 times square root of 3 is the square root of 3 squared, which is just 3. Or we could say that it's the square root of 3 squared. Well, then put a new page. Because we could say this as the square root of 3 squared. Square root and square would cancel, give us 3. Or we could say that it is the square root of 3 squared. Again, square root and square would cancel, giving us 3. And this last one's kind of going off the previous one. 3 times 3 is 9. Square root of 9 is still 3. So we're really saying that we have 3 here. Well, the I squared is going to turn this from positive to negative. So we really have 1 minus 3, which is negative 2. I have 1 negative I squared of 3. I have another telling me I have negative 2I square root of 3. And that's our final answer. Questions on this here? Are we ready for the next part? 3x squared minus 2x plus 5 equals 0. Well, if I was a betting man, I would assume that this has complex solutions. The whole chapter's section so far has been over imaginary, so most likely this has imaginary solutions. So there's only two ways that we can do this by hand, if you consider this by hand, because we are going to use the calculator for some of it. Two methods to solve it, besides just telling a calculator, solve this for me, is quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, and completing the square. Now the TI-89s, and pretty much some of the calculators after it, can actually solve these for us. Kind of nice. And the values of a, b, and c are coming from the general version of any quadratic equation, or ax squared plus bx plus c, where a is the value or the number in front of x squared, b is the number in front of x, and c is the constant term. So we have negative b, which would be negative, and we plug in our negative 2. Inside the radical, we have b squared, so negative 2 squared, minus 4. A in our case is positive 3, and c is positive 5. All over 2 times a, which is 2 times 3. Now at this point here, we'll do some simplifying. Our negative 2 is just 2. 2 times 3 is 6. Now normally, some will want to plug the whole thing in, but I do it part by part. I do the negative b, I simplify it first. I do the 2 times a, I simplify it. Our square root, I don't plug the whole thing in, because out of the two calculators, the graphing calculator does not like to leave it in radical form. It turns it into a decimal. But if it is an imaginary number, which we're going to get, it will reduce it to imaginary form, as long as the radical is nice. It'll still do it if it's not. It just gives us a decimal, which doesn't help us. The 30xs, this one here, will simplify in radical form, but it does not handle imaginary numbers. So we're kind of in a conundrum, yes? So what I do is I take the 30xs, I simplify what's inside, enter, we get negative 56. So I come back over here and say that this is negative 2 plus or minus the square root of negative 56 all over 6. Because if I wanted to, graphing calculator, second square root, negative 56, enter. It does reduce it, but that's not very helpful. The only reason that this is helpful is if we're actually solving for something, we're trying to find the exact value, then that's kind of helpful, but not too much. But I do know that whatever this comes out to be, we'll have I, because the negative and the negative 56 will come out as I, leaving us with the square root of 56. 30xs will simplify the square root of 56 to 2 square root of 14. So the square root of negative 56 is 2i square root of 14. Now all three of these terms do have a common factor of, and we can simplify that out. So our 2's on top will both become 1, because our 2, positive 2 real number is going to become 1. Our 2i is going to become 1i, or just I, when we do have square root of 14. The 6 will become 3. And that's it. if you are doing these by hand, if you can give me at least this, I will take it. That's even better, but I do want at least the first. Questions on any of this here? Questions on any of this so far? We feel good with these here? I think we feel comfortable with these. I would just use this quadratic formula and go from there. The only other thing I will add is powers of I. I don't think it's going to come up. But as we saw, I squared, we can't leave it as I squared. I to the n power, any power. I'm going to cover this briefly. I would definitely write this down. Because whenever we have an I to a power, we take whatever that power is and divide it by 4. And when we divide it by 4, we're going to get one of 4 decimals. .25, .50, .75, and .00. I mean, those are the only 4 decimals we can get when we divide by 4. Now, most likely, if you do get .00, it's just going to be a number. Calculators don't normally put that if it is shown up. .50 just shows up as 0.5. If the decimal is 0.25, it's going to reduce to I. If it's 0.50, it's going to reduce to -1. 0.75 is negative I. And 0.00 is 1. So if we have I to the 283 here, well, take 283 and divide it by 4. You can use the alpha y equals enter on the graphing calculator or use the fraction key on the 30xs. I would just use the division key. 283 divided by 4, because I want it in decimal form. Don't care about the 70. 0.75 is what's important. Since we do get a decimal as 0.75, this reduces to negative I. And that's it. All we do is take the exponent divided by 4. What you get from dividing the exponent by 4 is 0.25, you get I. If it's 0.50, we get negative I. Or not negative I, negative 1. 0.75 is our negative I. 0.00 is 1. Makes sense? And that's it. That is all we're doing today.